Hello friends. So, welcome to lecture series on essential mathematics for machine learning. So, in the last few lectures we have seen some of the basic concepts of calculus. We have seen that how we can define a function, what are various properties of functions, Jacobian, chain rule, etc. We have done only the simple concepts of chain rule. So, in this lecture we will try to see that what are the other concepts of chain rule or how can we use the definition of chain rule for solving various problems. So, first of all let us start with single variable function. So, we know that if z is a function of y for example and y is again a function of x, then if we want to find out dz by dx, so this is simply dz by dy into dy by dx. Okay. That I already told you, this is by the chain rule of single variable functions. Now, let us try to extend the same definition for two variable functions. Suppose z is a function of x and y, okay, and these x and y are independent variable of course, and x is again a function of t and y is some other function of t. Okay. Then if you want to find out dz by dt, see here they are the function of two variables, but when you substitute x as a function of t here and y as a function of t here, it will become a function of only one variable. So, since it become a function of one variable, then instead of using partial derivative, we will use total derivative, that is dz by dt. So, how we can define dz by dt over here? It will be, because z is a function of x and y are in turn other function of t, then this will be simply del z by del x into dx by dt plus del z by del y into dy by dt. Okay. So, this is how we can define a chain rule for two variable functions. Now, let us extend this definition for three variable function or n variable functions. Similarly, if we are a function of three variables x, y and w, x, y, w all are independent variables and all are in turn function of t. X is a function of t, y is a function of t, w is a function of t. Then if you want to find out dz by dt over here, then dz by dt is simply given by del z by del x into dx by dt plus del z by del y into dy by dt plus del z by del w into dw by dt. Okay. Similarly, if we are having a function of n variables, the same definition we can extend for n variable functions. Okay. So, see let us discuss few examples based on this for understanding it clearly. Say you are having a function of only one variable z as x cube and x is a function of sin t. So, how can you compute dz by dt? So, let us see. So, in this problem z is what? Z is x cube, okay, very simple illustration, and x is equal to sin t, x is a function of sin t. Okay. Now, if you want to compute dz by dt, this is equal to dz by dx into dx by dt by chain rule. What is dx by dt? It is dz by dx is what? Dz by dx is 3x square into what is dx by dt from here? It is cos t. And what is x? X is sin t. So, it is 3 sin square t into cos t. Of course, you can directly substitute x equal to sin t over here, then it will become z equal to sin cube t, and you can directly differentiate respect to t to find out dz by dt. But I want to illustrate you the how we can apply chain rule for this problem. Similarly, we can apply chain rule for two variable functions also. Okay. So, let us see one by one. Now, here in this problem 2, z is a function of x and y. What is z? Z is x sin y. X is a function of t and y is also a function of t. So, how can you compute dz by dt? So, what is z here in the second problem? So, this is first problem. In the second problem, what is z? Z is x sin y, okay. And what is x? X here in this problem is t square and y is 2t plus 5, t square and y is 2t plus 5, okay. So, to compute dz by dt, it will be what? Now, z is a function of two independent variables x and y, and x and y are in turn function of t. So, that will be del z by del x into dx by dt by chain rule plus del z by del y into dy by dt. So, that is equal to, it is del z by del x is what, sin y, okay. Dx by dt is what, 2t plus del z by del y is what, x cos y, and dy by dt is what, 2. So, now you can substitute x as t square and y as 2t plus 5. So, this is will be further equal to 2 times t, sin of y is what, 2t plus 5 plus 2 times x is what, t square, cos y is what, 2t plus 5. So, this is how you can find out dz by dt for this problem. Similarly, if you are having a function of 3 variables, okay, it is x square y cube z, x, y, z are independent variable, x is cos t, y is sin t, and say z is t square minus 1. So, how can you compute dw by dt over here? So, w is what? W is x square y cube into z, yes, and x is cos t, y is sin t, and z is t square minus 1. Okay. So, you have to compute dw by dt. So, again by chain rule dw by dt will be what? It will be del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. What is del w by del x? It is 2x y cube z, okay, and dx by dt is what? Minus sin t plus del w by del y is what? X square into 3 y square into z, dy by dt is cos t plus del w by del z is x square y cube into dz by dt is what? 2t. Now, you can further substitute x as cos t, y as sin t, and z as t square minus 1 in this problem to find out dw by dt expression in terms of t only. So, this is a simple implementation of chain rule. Now, let us compute other examples, let us discuss other examples. Now, see if you have a function of 2 variables, say z is a function of x and y, and x is a function of another 2 independent variables r and s, and y is also a function of r and s, then how can you compute del z by del r or del z by del s? So, see these things are very easy to understand. See, z is a function of x and y over here, okay, and x is again some function of r and s, and y is again some function of r and s. R and s are independent variables. Now, if you want to compute zr, zr is what? It is del z by del r. This is a simple notation, okay. Then del z by del r will be what? See, z is a function of x and y in turn function of r and s. So, that will be del z by del x into del x by del r plus del z by del y into del y by del r. And if you want to compute z s, which is what? Del z by del s. So, that will be simply del z by del x into del x by del s plus del z by del y into del y by del s. So, this is how you can compute it. Okay. Similarly, we can extend this definition, this concept to 3 variables or more than 3 variables. Okay. So, now for 3 variable also we can extend the same definition like this. So, let us discuss one example, say problem number 1 says that is a function of x and y, and x is equal to r cos theta, y equal to r sin theta, then how to compute del z by del r whole square plus 1 by r square times del z by del theta whole square. So, let us discuss this problem. So, what is z here? Z is a function of x and y, okay, and x is what? X is r cos theta, y is r sin theta, and you have to compute z r square plus 1 by r square times z theta square. This is to compute. So, let us first find del z by del r. It will be what? Del f by del x into del x by del r plus del f by del y into del y by del r. This is simply by chain rule, because z is a function of x and y are again function of r and theta. So, if you want to compute del z by del r, then this will be first del f by del x into del x by del r, and since f is a function of y also. So, del z plus del f by del y into del y by del r. So, this is further equal to, it is f x, okay. Del x by del r is what from here? See, r and theta are two independent variables. So, del x by del r from here is cos theta plus it is f y, del y by del r from here is sin theta. Okay. So, this is equation 1 for example. Now, del z by del theta you have to compute. This will be again by chain rule, it will be del f by del x into del x by del theta plus del f by del y into del y by del theta. So, that is further equal to f x into what is del x by del theta from here? It is minus r sin theta plus f y, del y by del theta from here is r cos theta. Okay. So, this further implies 1 by r z theta is equal to f x times minus sin theta plus f y times cos theta. So, now you can square and add equation 1 and 2. If you square and add equation 1 and 2, so we will obtain f z r square plus 1 by r square times z theta square, which is equal to, see, square and add will cancel the product term, and this square plus this square, because sin square plus cos square is 1. So, this is simply f x square plus f y square. So, this is your final answer for this problem. Okay. So, this is how you can solve this problem. So, similarly one can easily solve the second part of this this exercise. Now, before going to Jacobian and change of variable, let us first also see how we can find out second order partial derivatives or higher order partial derivatives using chain rule. So, for illustration, let us discuss one example. Suppose w is a function of u and v, okay, and say u is equal to x square minus y square upon 2 and v is equal to x y. Okay. Now, let us first try to compute w x x. Now, what do you mean by w x x? W x x is second order partial derivative with respect to x, that is simply equal to del square w upon del x square or del by del x of del w by del x. Okay. So, how can we find this using chain rule? So, let us try to find it here. Now, here w is a function of two independent variables u and v, and u and v are the functions of x and y. So, first compute del w by del x. Using that, we will try to find out del by del x of del w by del x. So, what is del w by del x first of all? It is by chain rule del f or del w by del u into del u by del x plus del f by del v into del v by del x by chain rule. Simply by chain rule we can easily write it. So, this is further equal to f u into what is del u by del x from here? It is x plus f v into what is del v by del y del x from here? It is y. Okay. Now, what is w x x, which is equal to del by del x of w x, which is equal to del by del x of x times f u plus y times f v. Okay. Now, let us apply product rule in this expression. So, it is further equal to first as it is derivative of second, that is del by del x of f u plus second as it is derivative of first, which is 1. Since x and y are independent variable, so y will come out and this is del by del x of f v. Now, here in this expression this f u is a function of u and v, which in turn function of x and y. So, we have to apply a chain rule in this expression itself. So, this is equal to, it is del by del u of f u into del u by del x plus del by del v of f u into del v by del x. This is by chain rule, okay, plus f u remain as it is plus y times. Now, again here this f v is a function of u and v are in turn function of x and y. So, again we will apply a chain rule in this expression. So, we will obtain, it is del by del u of f v, this will be into del u by del x plus del by del v of f v into del v by del x. Okay. So, let us try to simplify it, further simplify it. So, this will give, see, this is equal to, further equal to x times del by del u of f u is what? F u u, okay. I mean second order partial derivative with respect to u. What is del u by del x from here is x. So, it is x times plus what is del by del u of f u? It is f v u times what is del x by del v by del x from here? Y. So, y times this plus f u plus y times what is del by del u of this expression? It is del f of v u or u v into x times, because del u by del x is x, plus del by del u of this is f v v and del v by del x is what? Y. So, let us simplify it further. So, it is x square f u u plus. So, let us assume, so I am assuming here that f v u is equal to f u v. So, that means it is equal to 2 x y times f u v plus y square times f v v plus f u. So, this is the final, I mean final expression for w x x. So, similarly, if you want to find out w y y, so using the same lines we can easily find out w y y also. Or if you want to find out higher order partial derivatives, say w x x y or w I mean third order partial derivative with respect to x. So, using chain rule easily you can find out. So, this illustration will give an idea that how you can find out second or higher order partial derivatives using chain rule. Now, come to change of variables. So, how we can use this concept? So, let us see for two variable functions. So, let us suppose that is a function of x and y, and x is a function of, again is a function of u and v as we have already seen, and y is a function of u and v. Okay. Now, using this, if you want to find out del z by del u, see for example, here what is given to you, z is a function of x and y, yes, yes, and x is a function of some function of u v and y is again some function of u v. So, if you want to find out del z by del u for example, so that you can easily find out using chain rule, it is del f by del x into del x by del u plus del f by del y into del y by del u. Okay. Again, if you want to find out del z by del v, that also you can easily find out using chain rule, which is del f by del y into del y by del u plus del f by del y into del y by del v. So, here also it will be, okay, it is x, fine, sorry, it is del f by del x into del x by del v plus del f by del y into del y by del v. So, this you can find out easily, but suppose you are interested to find out del f by del x del or del f by del y. So, how you can find out? directly. So, we can use the concept of Jacobian. So, how Jacobian comes? So, let us try to see it from here. So, these are basically two equations. See, if we are having two equations, say a1x plus b1y equal to c1 and a2x plus b2y equal to c2 for example, and you are interested to find out x and y. So, how you find x and y? So, you use Cramer rule simply, x upon, and this is simply minus y upon and equal to 1 upon. Okay. So, what is x upon? This is determinant of, this is a matrix of determinant of, it is C1 C2 and it is B1 B2. Then determinant of, it is A1 A2, okay. Then it is C1 C2 equal to 1 upon determinant of A1 A2 B1 B2. Okay. So, this is how we can find out x and y, we already know this. So, this is also a system of linear equation with two unknowns x, this f x and f y. So, we can easily find out f x and f y using this rule. So, here this is A1, this is B1, this is C1, this is A2, this is B2, this is C2. So, what will be f x? So, this is f x upon, this is equal to minus f y upon, this is equal to 1 upon. Okay. So, what is f x upon? See, determinant of, this is C1 C2. So, what is C1? C1 C2. So, this is ZU, this is ZV, this is B1 B2, this is YU, this is YV. Here what is this? A1 A2. What is A1? A1 is XU, XV and C1 C2, that is ZU, ZV, and this is simply determinant of this term, that is XU, YU, XV, YV. So, simply you can use the first term and the last term to find out f x and the second term and the last term to find out f y. So, using this we can easily find out f x and f y. So, this term, this denominator 1 upon this denominator is called Jacobian, this Jacobian of x and y respect to u and v. Okay. So, the same concept we have used here to find out f x and f y. So, this is 1 upon j times, that is 1 upon Jacobian times. So, this is a denominator, this is j, I am writing it equal to 1 upon j. So, this is j. So, f x is what? This divided by j. So, this we have this it is represented by, this is given by del of f y upon del of u v, that is simply del f by del u, del f by del v, del y by del u, del y by del v, which is this expression, determinant of this. This is simply a notation, this term is simply given by the determinant of del f by del u, del f by del v, del y by del u, del y by del v, and similarly we can find out f y also. So, this is called basically change of variables. See, if you are having a in terms of u and v and you want to express you want to find out f x and f y. So, using this change of variable with the help of Jacobian one can easily find out. The same concept we can apply for 3 variables as well. So, these are the properties, I will come to these properties later. First for 3 variables functions, for 3 variable the same concept can be generalized. You can find out f x, f y and f z using the same concept. Okay. Now, come to the properties of Jacobian. The first property is that if Jacobian of j denotes del of x y upon del of u v and j dash denote del of u v upon del of x y, then this into this is always 1. See, Jacobian is a determinant which is simply a real number. Okay. So, if Jacobian is not equal to 0, then this into this is 1. It is all, it is I am not going to prove this over here, but I am simply illustrating you that these are the few properties of Jacobian. Now, the chain rule also hold in Jacobian. So, what is that? That is, if it is Jacobian of u with respect to x and y is equal to Jacobian of u with respect to r and s, and Jacobian of R and S with respect to x and y. I mean this is something like chain rule. So, the chain rule also holds in terms of Jacobian. Okay. So, these are few examples which we can easily find out using Jacobian. Say for example, the first problem, see z is a function of x and y. Okay. Let us try to find out z x over here. On the same lines we can find z y also. So, what is z x? See what is z here in this problem, what is z? Z is a function of x and y. Okay. What is x? X is e raised to power u into cos v. What is y? Y is e raised to power u into sin v. So, suppose you want to compute what? Zx, yes, Zx. Similarly, we can find zy also and square and add, we will get the answer of this problem. So, how to find out zx? So, for zx, just we have defined that fx or zx. Zx is simply first we find Jacobian and 1 upon Jacobian into Jacobian of this will give you the answer. So, first you find Jacobian. Jacobian will be given by what? Okay. So, j is del x upon del u. So, it is first you find Jacobian, it is what? Del x y upon del u v, which is determinant of del x by del u, del x by del v, del y by del u, del y by del v. So, this is equal to what? Del x by del u is what? E raised to power u cos v, e raised to power u cos v again, yes, and then del y by del u, it is e raised to power u minus sin v, and it is what? E raised to power u cos v, and determinant is simply what? E raised to power 2 u. So, this is Jacobian. Now, what is zx? Zx is as per the expression Jacobian of del of what? See, just now we have seen f y u, f y u v. Okay. So, it is f y del of u v. So, that is simply 1 upon e raised to power minus 2 u times determinant of del f by del u, del f by del v, del y by del u, del y by del v. So, it is further equal to e raised to power minus 2 u times determinant of what is del f by del u? Del f by del u can be determined by chain rule. So, it is del f by del x into, see, f u is del f by del x into del x by del u, which is e raised to power u cos v plus f y into del y by del u, which is e raised to power u sin v. Okay. What is f v? It is f x into del x by del v, that is e raised to power u into minus sin v plus f y into del y by del v, that is e raised to power u cos v. So, the entire expression we can write it over here. Okay. So, this is simply x times this plus y times f y, here it is minus y times f x in plus x times f y. Okay. What is del x by del u? We have just computed, it is this term which is minus y and this is x. Okay. Now, you can simply calculate this determinant, it is e raised to power minus 2 u times, it is x square f x plus x y f y minus it is minus y square f x, okay, and then it is plus x y f y. So, this is something your final expression which you can obtain for z x. Of course, these two terms will add up and it will be 2 x y f y. So, these are some illustrations that how you can find out f x or f y using Jacobian. So, in this lecture we have seen that how we can apply chain rule for 2 variable or more than 2 variable functions. Also we have seen that if we want to change the variables with the help of Jacobian, how can we do that? We have also solved few examples based on this for more understanding. Thank you.